Good day everyone, we are the group 9 and we will discuss to you the chapter 9 which is the computer system organization and architecture. So this lesson introduces the difference between computer organization and architecture, which is the study of internal working. It also includes the functional view of von Neumann model, data presentation, and number system. And by the end of this lesson, students will be able to define and discuss computer organization and computer architecture, identify the different units of measure common of computer systems, discuss and explain the components of von Neumann architecture and the functions of basic computer components and computer number system for its equivalent representations. I am Miah Matugas from BED 1A and I will discuss the difference of computer organization and computer architecture and the attributes of the two. So computer organization is the study of the system from software point of view and gives overall description of the system and working principles without going into much detail. It is the way a computer components are arranged and how they interact with each other to perform a task. It is the physical and logical design of the computer. Sa madaling salita, ang computer organization ay tungkol sa kung paano nagtutulungan ang mga bahagi ng computer upang magpatakbo ng mga programa at impormasyon. On the other hand, computer architecture is the system from hardware point of view and emphasis on how the system is implemented, the design and the organization of the components that make up a computer system. So, to fully understand the two, let us differentiate what is computer organization and computer architecture. So, when we say computer architecture or architecture, it is the structure and behavior of a computer, the logical design of computer. It is like the blueprint or a plan for how a computer is designed. Pinapakita nito kung paano nag-work together ang mga parts ng computer. Katulad na lang sa pagpapagawa ng bahay, kailangan mo ng instruction, kailangan mo ng plano kung paano ito patayuin. And on the other hand, when we say organization, it is the interaction with the computer. It is the physical design of computer. It is about how these parts are put together and work in the real computer. It is like, kapag nakapagpatayo ka na ng bahay, kailangan mo na ng parts nito, ng mga windows, bricks, and doors para mapatayo ito ng maayos. So, in a simple word, computer architecture is the plan and computer organization is how the plan gets built and work in real life. Now, let us discuss the attributes of computer organization. First is the control signal. It is a pulse or frequency of electricity or light that represents a control command as it travels over a network, a computer channel, or wireless. Control signals are instruction that guides computer parts like the processor, memory, and screen to work together. They are sent by the control unit acting as the boss or the director, ensuring everything happens at the right time. Without control signals, computer parts would not know what to do, making them crucial for smooth computer operation. The next one is the computer peripheral interface. Peripheral is a device that is connected to a host computer but not part of it, such as a mouse, keyboard, printer, or a speaker. Interface is the point of interaction with software or computer hardware, or with peripheral devices such as a computer monitor or a keyboard, as I said earlier. So the interface helps all the different parts of a computer communicate and make things work properly. There are two types of interfaces, hardware interfaces and software interfaces. When we say hardware interfaces, help different physical part of a device like a computer or phone connect and work together like USB ports. Software interface help different apps or program talk to each other and share information such as how a photo app saves picture. In a simple term, hardware interface connects the part and software help the apps work together. And last attribute of computer of this is the memory. It stores all the information the computer needs to work, like instruction for running programs and data the program use. Now let us define the computer architecture. So, as I said earlier, it is like a blueprint for how a computer is built and works. It explains how the different parts of a computer, like the hardware or the physical part and the software, the programs, work together. It is also show how a programmer sees and interacts with the computer when writing code. In simple terms, it's the plan and rules for designing a computer so that everything works well together. So, here are the other definitions according to Baer. The design of integrated system which provide a useful tool to the program. He means that an integrated system is a collection of tools that work together to help programmers to do their work faster and more efficiently. And next is, according to Hayes, the study of the structure, behavior, and design of computers. So Hayes is talking about learning how computers are built, how they work, and how we design them. There are also other definitions that you can see in the PowerPoint presentation. Now let us move on to discuss the attributes of a computer architecture. First, it is the instruction set architecture or the ISA. It is the part of the processor that is visible to the programmer or compiler writer. It is served as the boundary between software and the hardware. It is like the manual for how a computer processor carries a command. That is the instruction set architecture. Next is the data presentation. Data presentation refers to the method used internally to present information stored in a computer. From the word presentation, present, ipinapakita. Data presentation in computer architecture is how computer stores and organize information so they can understand and use it quickly, like organizing a library for easy access. Next one is the I/O mechanism. It is the communication between an information processing system. For example, kapag nagtatype ka sa keyboard, naglagay ka ng hello world. Hello world is the input. When you press a key on your keyboard, input na yon. And the computer takes that information and show a letter on your screen, that's the output. So, pag nag-type ka ng hello world, tapos nakita mo siya sa screen mo, sa laptop mo, sa computer mo, that is the output. So, the I/O mechanism makes sure this communication happens smoothly. And next one is the addressing techniques. The addressing techniques are an aspect of the instruction set architecture in most central processing unit or the CPU designs. In computer architecture, addressing techniques are like different ways to give directions to a specific place in computer memory. For example, pag pupunta ka sa ibang bahay o pupunta ka sa ibang lugar, kailangan mo ng address para makapunta ka doon. So, computers use addresses to find information in memory. And now let's see the structure and functions of a computer. A complex system, it is how can we design it or describe it. Another one is the hierarchic system. It is a set of interrelated subsystem, and at each level of the system, the designer is concerned with structure and function. A hierarchical system in computer architecture is like a big team where everyone has a specific job, and the jobs are organized in layers or level, like the CPU, RAM, and the storage. So, structure is the way in which components relate to each other, and function is the operation of individual components as part of the structure. And these are the basic computer functions. Number one, it is the data processing. It refers to the process of collecting and manipulating raw data to yield useful information. Number two, it is the data storage. It is a general term for achieving data in electromagnetic or other forms for use by a computer or device. For example, hard drive, RAM, or solid state drive. Next one is the data movement. Computer must be able to communicate with the outside world. It is the process of transferring information from one place to another. Data must be accessible to devices outside computer. Data movement, from the word movement, lumilipat or palipat-lipat. And there are two types. It is the peripheral and data communications. And lastly, the control. It is something needs to monitor operation and maintain control of the data processing, data storage, and data movement. Automated control of computer resources. Control in computer architecture is the part of the system that directs operations and manages how components work together. So that we are now done defining the computer organization and computer architecture. Now let us move on to the next topic.
A blessed day to everyone of us. My name is Rose Ambrocio, and today I'm going to discuss the functional view of von Neumann model. When we say von Neumann model was designed and developed by the great mathematician and scientist named John von Neumann model. Von Neumann model was consist of five major components, and today we're going to discuss the five major components of von Neumann model. The first one that we're going to discuss is the input. When we say input, is comes in getting information to the computer. The major components of input comes through input device like keyboard or mouse. The second one is memory. The memory is the storage of information, data, or process. The data temporarily stores in the memory that we called RAM. And the third one that we're going to discuss is the process. Dito sa process na to is may two parts which is the ALU or the arithmetic and logic unit na kung saan a unit of computer which carries out arithmetic and logic operations make to perform mathematics functions such as addition, subtraction, like that. And siya naman, ito yun naman yung tinatawag nating control unit na kung saan dito niya make sure that all the other parts perform and correctly and at the correct time. Nagagawa nila yung task nila at the correct time. Pagkatapos na naasikaso ni control unit nito, pupunta na siya sa output na kung saan dito get the information in the computer or dito na yung mga lumalabas sa ating printer or monitor. Tatalakayin and the system bus model na kung saan the system bus model has three major components. Nakatulad din kanina sa diniscuss that they have a CPU or the central processing unit, the process data, memory units that holds data for processing, and the input and output unit that is used by a user to communicate with a computer. Now, we're going to discuss about the different types of buses. Okay, the first one is the control bus. Okay, kapag sinabi natin control bus, it is a computer bus that is used by the CPU to communicate with devices that are contained with computer. Tumutukoy ito sa physical or connections such as keyboard or printed circuits. Yun naman is yung address bus na kung saan ito ginagamit used to transfer data between the devices that are identified by the hardware or address of the physical memory na kung saan dito in-store in the form of binary numbers to enable the data bus to access memory storage. Kapag data bus naman, dito yung system na within a computer or device consisting of a connector or set of wires na kung saan siya yung provides ng transportation for data. That's for all. Thank you.
Hello everyone, I'm Maxine Joy Yoro, member of Group 9 and looking forward to discuss about motherboard with you all today. A motherboard is the main circuit board of a computer or other electronic device. It contains the essential components such as microprocessor, CPU, memory, chipset, and connectors for peripherals like USB, audio, and video. So, the motherboard acts as a backbone allowing other circuit boards like graphics cards, sound cards to be connected to it, expanding the device's capabilities. The NOR bridge is a chip that acts as a controller connecting the CPU to memory via the frontside bus or FSB. peripherals to the system via high-speed channels like AGP, Accelerated Graphics Port, PCI Express, or Peripheral Component Interconnect Express. In essence, the North Bridge manages the flow of data between the CPU, memory, and high-speed peripherals. The South Bridge is one of the two main chips on a PC motherboard's core logic chipset. It handles the motherboard's lower functions such as USB ports, audio and video outputs, storage device connection or IDE SATA, power management, peripheral connections, PCIe, while the North Bridge handles faster functions like connecting the CPU to memory and high-speed peripherals. A system bus is a communication pathway that allows different computer components to exchange data with each other. It's like a highway for data, connecting the microprocessor or CPU, main memory, and other peripherals and components. The system bus consists of cables and connectors that enable the transfer of data, instructions, and signals between these components. It's a crucial part of a computer's architecture, facilitating communication and data exchange between various parts of the system. The term system bus is related to the word omnibus, which means for all or a vehicle for everyone. Similarly, a system bus is a shared communication pathway that allows multiple components to exchange data with each other. The control bus is one of the three main buses that make up the system bus. Its primary function is to carry control, timing, and coordination signals that manage the various functions across the system, where are as follows. The control bus determines how data is processed and manages the flow of data between different components. It ensures that data is transmitted and processed correctly, and that the system operates in coordinated and efficient manner. The address bus is another key component of the system bus. Its primary function is to specify the memory locations where data is to be transferred. In other words, the address bus determines the destination of the data, telling the system where to send or retrieve the data. It provides the memory address, allowing the system to access and manipulate the correct data. And lastly, the data bus is a bidirectional pathway that carries the actual data between the processor or CPU, memory, peripherals, input or output devices. Its primary function is to transport the data that needs to be processed, stored, or transmitted. The data bus enables the exchange of data between different components, allowing the system to perform various tasks and operations. Thank you.
Good day everyone, my name is Glenda Paulino and I am here to discuss the digital components. So let's proceed to the transistor. So when we say transistor, it is a semiconductor device used to amplify and switch electronic signals and electrical power. So karamihan sa mga technology na nasa paligid na hinahawakan natin, ito ay binubuo ng transistor. Isa na nga dyan ang mobile phone, yung mga desktop, laptop, or even smartwatch, television, at marami pang iba. So, sobrang lawak ng ginagamitan ng transistor kaya napakahalaga ding may ideya tayo, specifically sa mga engineer, technician, and also the student. So, when we say transistor, it is a semiconductor component na ginagamit as a switch and for amplification of signal. And it is made of semiconductor chemical elements, usually silicon. Ngayon, kung may pure silicon tayo na kailangang mag-conduct ng electricity, kinakailangang mag-absorb ng energy ang electrons natin at sila yung magiging free electron. Yan yung dahilan kung bakit ang pure silicon ay meron siyang low electrical conductivity. So, parang useless na yung original form ng ating pure silicon. So, dyan napapasok yung tinatawag nating doping. Kapag sinabi kasi nating doping, ito yung ginagamit nating technique to improve conductivity ng isang semiconductor. So, ito yung pag-i-inject natin ng foreign material para ma-enhance yung performance. So, let's proceed to the microelectronics. So, when we say microelectronics, it is a field of electronics that utilize a tiny and macro components to manufacture electronics. So, as a demand for a small and the less expensive devices grows, the field continues to expand. The main areas to focus generally are search for reliability and manufacturing. So, the traditional electronic designs in a components we have around us that can be found in manufacturing forms. The components that make up the manufacturing devices comprises of capacitors, transistors, diode, inductors, conductors, and insulators. So these are well micrometer scale design in devices in which they are found. Next is the level of integration. So an integrated circuit is actually an electronic devices that gathers or integrates a number of electronic components to the small semiconductor. So here are numbers of gates in integrated circuit. First is the small scale integration. So we have 10 to 100 gates. Next is the medium scale integration. We have 100 to 1000 gates. Next is the large scale integration. We have 1000 to 10,000 logic gates. And lastly, the very large scale integration, we have 10,000 upward. So, let's proceed to the data representation. So, when we say data representation, it is a common form of data or letters of the alphabet A to Z, numerals 0 to 9, some symbols, and certain control characters. So, this type of data is convenient for human being, but all of the data in digital computers represented in binary form. The famous coding system being used for data representation are: first is the ASCII, or stands for American Standard Code for Information Interchange. It is used to represent text in computers, telecommunication equipments, and other devices that use text. And each character, letters, digits, punctuation mark assign a numerical value, typically a 7-bit binary number, and we have a 128 possible characters can be represented. Like for example, character A is equal to 65 in decimal and 41 in hex. Next is the EBCDIC, or stands for Extended Binary Coded Decimal Interchange Code. It pronounced either EBCDIC or EBCDIC. Each alphabetic or numeric character is represented with 8-bit binary number, and we have a 256 possible characters. Like for example, character A is equal to C1 in hex and 11000011 in binary. And lastly is the BCD, or stands for Binary Coded Decimal. We have a 4-bit binary number were used to represent in one decimal number. Like for example, to encode the numbers such as 43D, you can use 01000011B. So that's all.
Good day everyone, I am Jona Carasi, and I will be discussing the number of system and the type of number of system. Number system. It's fundamental to understand how computer work is. Understanding the number system that computer use to store data and communicate with each other, and also number system being used to understand computer. And these are the type of number system: decimal system, binary system, octal system, and the hexadecimal system. First is the decimal system. This system is commonly used by human being for counting. The symbols used called are Arabic numerals, consisting of 10 symbols: the 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. The base of the decimal system is 10. It is important because it is the most widely used number system in daily life, commonly used in counting, calculating, science, technology, and also in education. The second one is binary system. This system is used in digital computers. They operate in either one or two states, either on or off, positive or negative. It uses only two symbols, the 0 and 1. The base of the binary system is 2. The binary notation 0 and 1 are called bits, which is an acronym of binary digit. It also crucial for digital computing and modern technology for several reasons. First, compatibility with digital circuit. Computers and electronic devices use binary because digital circuit have two states, on 1 and off 0. These two states align perfectly with the binary system. It also important in universal standard. The binary system serves as a universal standard for all digital technologies, whether it's software or hardware or data transmission. Everything in the digital world released on binary to function ensuring consistency across all systems. The third one is the octal system. This system is a shorthand digit to reduce the number of binary digits by single octal digit to reduce the number of digits required to representing any number. It has a base of radix 8 consisting of 0, 1, 2, 3, 4, 5, 6, and 7. The base of the octal system is 8. In the binary system, numbers are made up of only 0 and 1, which can become long and difficult to manage. The octal system helps by grouping every 3 binary digits onto one octal digit. This makes it easier to work with large binary numbers as you only need fewer digits to represent the same values. The last one is the hexadecimal system. This system is the simplest method of expressing value, represented by binary numerals. It is the combination of the 10 numbers and 6 alphabets. The 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, and the alphabet A, B, C, D, E, and F. The 6 alphabet represent digit 10 to 15, and these are treated as ordinary numerals. The base of a hexadecimal system is 16. The hexadecimal system is commonly used in computer, helping in debugging, easy conversation, and shorter and easier.
So good day everyone, I am Stephanie Tierro and I'm here to present the conversion from one number system to another and also the number system conversion. So first, let's go to the conversion from one number system to another. In mathematics, a number can be converted to a different number system. For example, into Arabic can be converted to Roman numerals and vice versa. Similarly, all four number system. So iniisip nyo kung ano yung four number system. Ito yung types of number system na decimal, binary, octal, and lastly, the hexadecimal. computers are equally capable of representing any number. Furthermore, a number can be perfectly converted into the various number system without any loss of numeric value. It's like translating the meaning of a number from one language to another. So we find the equivalent representation of the number in the new system. So I'll be giving you an example. It's like um, you're translating the word hello into the Tagalog, which is magiging kamusta. Mapapansin nyo dito na mag-iiba yung representation niya. Pero, dito nyo rin mapapansin na iba yung representation niya, pero same meaning pa rin. And kaya dito nasabi na converted into various number system without any loss of numeric value. So, next, ito yung table ng decimal, binary, octal, and hexadecimal number. So, next, the number system conversion. To convert decimal to any system, repeated division by the number systems base technique is used. It's the process of the changing the way a number is written to represent the same value in a different number system. So, next is, ito yung step na gagawin natin para ma-convert yung decimal number sa new base. Ang gagawin natin dito ay, yung decimal number na represent ay i-divide natin siya sa base sa different base. Which is, pag ginamit natin si binary, ang base nun is 2. Pag si octal naman ay 8, and lastly, si hexadecimal ay 16. So, pagka-divide natin doon sa mga base nun, ay pagka-kuha natin ng product, pag na-divide na natin yun, ay ilalagay natin yung reminder niya. And pagtapos nun, uulitin mo lang yung process nun hanggang sa maabot natin yung 0 na quotient. Tapos, pag naabot na natin yung 0 na yun, ay kukunin natin lahat ng naging reminder niya. Pero, pataas natin siya kukunin. So, itry natin isolve yung example dito ng decimal to binary. So, yung 74, ito yung decimal number. And yung 10, ito yung decimal base. And yung binary. And yung N2 is yung 2 doon, yung base, and yung number, yung N. And 74 divided by 2 is equal to 37. Reminder 0. 37 divided by 2 is 18.5. Pero, kaya naging reminder 1 yan. Sa may di nakakaalam, is, ang gagawin natin ay 2 times 18 is equal to 36. So, pagkakuha natin 36, i-minus natin siya sa 37. Kaya, equal nun is 1. Kaya nakuha si 1. And ulitin natin yung 18 divided by 2 is equal to 9. And the 9 divided by 2 is equal to 4. Same procedure lang sa pagkuha. Hanggang sa naabot na natin tong 1 divided by 2 is equal to 0. Reminder 1. So, ang gagawin natin dyan, kukunin natin yung mga reminder niya, pataas siya. Unahin natin yung 1, next is 0, and also the 0, 1, 0, 1, 0. Kaya nakuha si 110, 10, and base ng 2. This is the decimal to octal. Same procedure lang. And yung set 74 din is yun yung decimal number niya. 74 divided by 8 is equal to 9.25. So, yun yung makukuha natin. Paano nakuha yung reminder 2? Same procedure. Yung paano natin siya nakuha is 8 divided by 9 is equal to 72. And i-minus natin siya sa 74 na decimal, kaya nakuha si 2. Yan. And same procedure lang, ganun lang gagawin natin. Pagkakuha na natin, reach na natin yung 0, kukunin na natin siya pataas na kagaya nito, 1, 1, 2, base 8, kaya nakuha yung octal number. And next, the decimal to hexadecimal. Same procedure lang din. 74 divided by 16, it's equal to 4625. So, naisip nyo kung paano rin nakuha yon. So, 16 divided by 4 is equal to 64. Minus 74, yung decimal. Makukuha natin is 10. So, iniisip nyo kung ano yung, bakit may A dyan. Kasi, doon mag-start, 10 kasi nag-start si decimal, kaya naging 16 rin yung base niya. And ABC rin yung ginagawa niyang represent, kaya naging 10 or A. So, pagkatapos nun, kunin natin siya pataas, kaya nakuha si 4A base 16. Next naman is yung, i-convert natin yung binary sa octal, hexadecimal, decimal, and ito yung procedure niya. Starting from the right base, which is the 2 for binary, 8 for octal, and 16 for hexadecimal, will be raised to the power of 0. The next number to first, the third number to the second power, etc. Get the sum of all numbers and the answer represents the decimal number. So, itry natin tong example na binary to decimal. Yung nakalagay dito sa 010 0101 001. Si 01, assist kay 0 muna tayo. 0 times 2 is equal to 0. So, iniisip nyo bakit may 1 na dito sa may pangatlong row. Kasi, sa rule ng exponent is yung 0 is magiging 1 siya. Wala siyang calculation. Kaya, naging 1 yon. And, same procedure lang. I-times muna natin. 1 times 2 is equal to 1 times 2 it's equal to 2. And i-write down natin din sa pangatlong row. And same rin yung and so on and so forth. Same lang sila. And pag nakuha na natin yung nasa may yung pangatlong row, yung last naman na pagta-times. 0 times 1 is equal to 0. 1 times 2 is equal to 2. 0 times 4 is equal to 0. And 1 times 8, 8. 0 times 16, 0. 0 times 32 is equal to 0. And 1 times 64 is equal to 64. Pag na-total natin siya, makukuha natin si 74. And next, yung octal to decimal, same procedure lang sila hanggang sa makuha mo yung 74. Pati rin yung sa may decimal to hexadecimal. Hanggang sa makuha lang natin si 74. Ayan, okay na siya. Next, ito naman na yung converting binary to octal or hexadecimal. Ito yung steps niya para makuha. I-divide the binary digits into groups. 3 for octal and 4 for hexadecimal. Fill in with 0 to the left of the first digit of the given number in order to complete the groupings. Using the place value of the binary system and the positions with corresponding 1 digit or bit. So, yun. I-try natin yung example niya dito. Yung binary to octal is yun. Yun ang i-try muna natin. Yung 1, 0, 0, 1, 0, 1, 0, base 2. I-groups natin siya. First group natin ay 0, 1, 0, and next the 0, 0, 1. And sabi doon, mag-add daw ng zeros pa left side para makumpleto yung groups. Mag-add tayo ng 2 0. Pagkakuha niyan, bring down natin. pagka-bring down natin is ilalagay natin dito sa may, dito is 1, 2, 1, 2, 1, 2. So, 0 times 1 is equal to 0. 1 times 2 is equal to 2. And next is 0 times 1 is equal to 1. 0. 1 times 1 is 1. 2 times 0 equal to 0. 0 times 1, 0. 1 times 1, 1. 0 times 2 is equal to 0. 0 times 1 is 0. Is makukuha natin dito ay si 1, 1, 2. And yun yung nasa taas na 1, 1, 2, base 8. And ganun rin yung gagawin sa may binary to hexadecimal. Itatry natin siya. Try natin kunin siya. So, i-bring down natin. Same rin yung group. No. Kasi 3 kasi kay binary pala. Binary to octal is 3 per group is 3 siya. Kay hexadecimal naman ay 4. Baba natin si 1, ilagay natin si 100, 0, 1, 0. Ayan. Base 2. And pagkatapos nun, igrupo na natin siya. At ang first group ay ang 1, 0, 1, 0. And next ay may tatlong groups lang. May tatlong bali 3 lang yung nakalagay dito. Kulang siya ng isa kaya mag-add tayo ng 0. Pagka-add, baba natin yung groups niya. 0, 1, 0, 0, and 1, 0, 1, 0. Pag na-bring down na natin is i-times na natin siya. Yung first 10, i-times natin siya sa 0. Makukuha natin is 0. Yung second 10 is 1, which is makukuha natin si 10. Or A. Yung isa is 0 times 4, 0. 0 times 1, 0. 1 times 4 is equal to 4. 0 times 1 is equal to 0. Kaya si 4A or 10, base 16. Naman yung convert each octal digit, 3-bit pattern for octal and 4-bit pattern for hexadecimal. The zeros to the left of the most digit are ignored. Yung nasa left daw is ignore natin siya. So, ignore natin to. Ignore. Yan. So, try natin yung example. Binary to octal. So, ibababa natin itong 1, 1, 0, 0, 1, 0, 1, 0, 1, 0. Sakto na. Ay, sobra. So, sabi niya dito, 3 bits pattern. So, tagtatatlong ko na din. Yung una is 1, 0, 1. Ay, no. 0, 1, 0. Next is 0, 0, 1. May sobra na 1. Kaya, sabi din is mag-add para makompleto yung groups. Pero 0 i-add. And yun, 0, 0 rin. And dito, ang pagkalagay natin is ilagay natin ng 0, 2, 0, 1, 0, 0, 1, 0, 0. Kaya makukuha natin si 2. So, second is 1. First is 1. Kaya makukuha natin si 112. Si 112. Next, yung kay binary to hexadecimal naman. Kay binary to hexadecimal naman is same procedure lang siya. hanggang sa makuha si 4A or 10 4A10 they call this one base 16. Yun. Hanggang sa makuha natin yun. Yun lang. That's all. Thank you.